Okay, so I'm going to pick back up where I left off. So if I look at just the red, the orange, and the yellow bubble tubes, and I compare them to the green, the blue, and the violet, some of the times I saw from people in class were, or excuse me, some of the distances. A lot of you said that the size of the tubes themselves were about 80 centimeters, which is about 0.8 meters. And many of your numbers were between 6 centimeters per second and 8 centimeters per second. So I'll just pick 7 centimeters per second. We'll say that the red, the orange, and the yellow bubbles traveled up at about 7 centimeters per second. And the whole number is probably the best way to go about doing this. And you would have found that the green, the blue, and the violet would have traveled a little bit slower. So your velocities were kind of plus or minus. So I'll just call it 5 centimeters per second. So you have the tape here where I have these darkened in, and I asked you to find where the y-intercept was. And a lot of you don't realize that what you could do is simply, if you invert the tube upside down, right? So if you invert it and you time how long it takes, right at this point right here. So let's say you have it inverted. It doesn't matter which color. If I call this one here red. So I take this one and I flip it upside down so the bubble travels up. You could have timed it and you would have had a time. So let's just say for instance, we know that the velocity here, and this is your numbers. I want you to use your actual numbers. You don't have to use this one. I was just using I was taking notes today from class, from what students were doing. So the distance is going to be, so I'm going to use my velocity here, 7 centimeters per second. Well, let me change that. It's kind of a funky 7. And let's say it took 10 seconds, just for the sake of conversation. So this would tell me that the distance would be 70 centimeters. Well, what I could do then, you know what, let me go grab a meter stick. I would actually then just measure where 70 centimeters is on one of the tubes. And I want you to see this here, that if I measure 70 centimeters from the top here, so if I look here, so here's my 0 point, so I move all the way down 70 centimeters, which is actually a legit number, could be. 70 centimeters means that my y-intercept would be right here. But my y-intercept isn't 70 centimeters. I would measure it from 0 is at the bottom. So if this is the bottom here, I would find that my y-intercept would be, those are my fingers right above this stopper here, would be about 9 centimeters, right? It's simply saying that it's 9 centimeters above 0. This is really hard. I'm doing all this with one hand, so bear with me for a second. If I see this here, right? So if this is my 0 point, remember my 0 point isn't that part. So maybe it's actually closer to 8 centimeters. So my y-intercept would be 8 centimeters from the bottom. And I can do that for each one of these. You should have been able to find that your red, your orange, and your yellow with the same velocity, and 7 was just my example. And that in order to find the distance in which the bubble traveled at a rate of 7 centimeters per second, it traveled for 10 seconds, it would have traveled 70 centimeters. And then I simply just kind of backtrack and I just calculate it. That would have been, what did I say, 8 centimeters from the bottom. And that would have been my y-intercept. And I would need to do that for my red, my orange, and my yellow, because it would have taken them different times to travel all the way up the bubble tube. And then I would do that for my green, my blue, and my violet. I hope that makes sense. That should be enough to help you complete the lab.